All right, here we go. We got operations on functions. We got composition of functions today. This first slide said if you want to add two functions, just add them together. Subtraction, multiplication, division, you just do the operation. So let's just go to the example. I think that's the best way to go here. Let f of x equal 2x minus 7 and g of x equal x squared plus 4. Find f plus g. So we're doing 2x minus 7 plus x squared plus 4. And collect like terms. So x squared plus 2x minus 3. So the only thing you can combine on this one, negative 7 plus 4 is negative 3. So it doesn't get much easier than that in my opinion. So hopefully that's an easy problem for you. Now with subtraction, you have to be a little bit more careful. We have 2x minus 7, then minus x squared plus 4. The trick is you're minusing both of them, not just the x squared. So we have to think of minusing both of these. That's going to be a negative x squared plus 2x, because we're not really combining those with anything, other than now that x squared is negative. Here's where you really have to be careful. Negative 7 minus 4 is now negative 11. So it changes things a little bit. It makes that negative, that x squared negative, and we're actually subtracting that 4 also. Gotta be careful. And how about multiplication and addition? With multiplication, it doesn't matter. Well, I guess we can do it like this. We'll go 6x squared plus 7x minus 5 times 2x minus 1. Now we're multiplying. So what you can do is you can distribute the 6x squared through. That's 12x to the third minus 6x squared. So we distribute the 6x squared. Now we can distribute the 7x, which will be plus 14x squared, and then minus 7x. And then we can distribute the negative 5 through. So you just take terms. That's negative 10x plus 5. And I line it up like that so that when I collect like terms, they're lined up vertically. So it's easy to find them, in my opinion. So we have 12x to the third plus 8x squared minus 17x plus 5. So with multiplication, there's a little bit of work involved. Go ahead.
Doesn't it work exactly the same though if you just like instead of going 3, you just use these 2 and
Yep.
go over? Yeah.
It'd be the same answer. That's right. Yep. And then g over f. So 2x minus 1 over 6x squared plus 7x minus 5. Now, what we have to look at here is does that factor? Actually, I don't know if it factors. Let's find out. 10 and 3. Yep, I think it does. So we have, there's a good chance it's 2x minus 1 and x plus, oh, wait. That'd have to be a 3. That'd have to be a 5, right? So we'd have positive 10x minus 3x. And the reason we want to factor is because now these cancel out. So the answer is 1 over 3x plus 5. Now you want to check to see if that happens. If it doesn't factor, you're done in one step. If it factors, you got to cancel it out. Any questions on that? It has to be exactly the same. I hope that's obvious in order to cancel. Composition of functions. The composition of a function g. If I run into you, I apologize in advance, all right? G with a function f is. G of f is the same as, this is the same as this. It means the same thing. It's read as g of f of x. This is read the same. G of f of x. You just put of in those spaces. Work from the inside out. Here's an example. We're going to work from the inside out. We're going to find, this says find g of f of 5. That's how you say it. So we're going to find f of 5. We're going to replace f of 5 with whatever value we get. So I'm going to plug 5 in for f right here. That's 15 minus 8. The result is 7. So now I will replace f of 5 with the number 7. So now it's g of 7. F of 5 became 7. Now I plug 7 into g. So that's 2 times 49 that ends up being 98. So the final answer for this is 98. You work inside out. You do the F first. Whatever you find, you do the G of that. G of 5. G of 5. Oh, we're going backwards. All right. So now I plugged 5 in for G. 2 times 25, that's 50. Now I'm finding F of 50. I found the G of 5. Turned out to be 50. Make the replacement. Find F of 50. That's 150 minus 8. 142. Inside out. You always work inside out with those. F of G of negative 2. You do G of negative 2 first. So negative 2 plus 4 turns out to be 2. Now we're going to do F of 2 because we did the inside, we did the G, now we have to replace that and do the F. So F of 2 now is 4 minus 7. The answer is negative 3. Let's do, on this one, there's no value to plug in because it says X. So we take G times F. X plus 4 times 2X minus 7. That's FOIL, right? 2X squared. We have minus 7X plus 8X. That's plus 1X minus 28. But we got this 2 sitting out front. So we FOILed, and now we just distribute the 2. 4x squared plus 2x minus 56. So on that one, you're going to do the multiplication first on the functions, and then multiply all of it by 2. That's how I'd work that problem. Any questions on that? Keep rolling. Let f of x equal those two. Oh, why is it? Oh, this is supposed to be like, can I move these? One page? There we go. There we go. Now I have a little more room. Example, let f of x equal 2x minus 7 and g of x equal x plus 4. We have g of f of x, and I like it written like this, g of f of x. Now this gets a little more trickier when you don't have a value, when you just have x's. What I want to emphasize on this is a replacement. What we're going to do is we're going to put f inside of g. I'm going to take this right here, and I'm going to replace that x. It's not multiplying. When it's that open dot, that is not multiplying. That means a replacement. It's called a composition. You're composing the two functions. So instead of x plus 4, I'm going to have 2x minus 7. 2x minus 7 plus 4. Because the g was x plus 4, and I've made the replacement. And you replace the inside goes into the outside function. So the answer to this one is 2x minus 3. It's a replacement. Now that's not all that important when you're not doing much to x. But now what about the other way around? We're plugging g in for just that x right there. It's a replacement. So now the 2 is on the outside. I'm replacing x with x plus 4. And then minus 7. It was 2x minus 7, but we've replaced the x with x plus 4. Well, now we distribute. So that one is 2x plus 1. That's what you get when you do the composition the other way. Plug the inside into the outside function. It's a replacement. It gets a little more complicated when you start having powers. So let's try g of f, or excuse me, f of g of x. We take the inside function. We are plugging that in for that x. We are replacing that x. Everything else stays exactly the same. The squared stays there. The plus 11 stays. The x is getting replaced. Negative x minus 2 squared plus 11. The squared stayed there. The 11 stayed there. That didn't change. The x was replaced. Well, now we have to square these, which means you have 2 of them. You do not square the x and square the 2 and call it good. You can do that, but it's completely wrong. Squared means there's 2 of them. All right, so x squared, negative and negative is a positive. Outside would be 2x. Inside would be 2x. That's plus 4x. And then the last would be plus 4. But then from that other function, we got the plus 11. So this is x squared plus 4x plus 15. Inside plugged into the outside. G of f is f replaced into g, plugged into g, f into g now. So now we're going the other way around, which is probably a little easier because we don't have to square anything. We're going to plug that in for that x right there. So we have negative x squared plus 11 and then minus 2. So I've replaced that x. Everything else stayed the same. We have the negative and we have the minus 2 still there. Go ahead.
I thought the closed dot was
Oh, yeah. No, yeah, thank you. Yeah, that's what they're doing. Closed dots multiply. Oh, you saved me. Closed dots multiply. I got rolling on this composition, didn't I? Okay, so we'll times. G distribute that through. Should we do that? Oh, we can FOIL this. We can FOIL. First, negative x to the third. Outside, minus 11x. Inside, minus 2x squared. Last, minus 22. I know that probably doesn't bother you, but it bothers me that it's out of order. Try to put those in order, please, from highest to least power.
So if it's a closed dot, you multiply?
Closed dot multiply. We're going to go with your idea. Open dot composition. That's the rule. If it's different, I'll let you know. For right now, that's the rule. Oh, ta-da, there we go. Page 389, number 8, 14, 28 to 30 all, 38 to 45 all. Make sure you follow the directions it says. Do not do the restrictions on the domain and the range. We're not doing domain and range. Not yet, anyway. Just do the composition. Yep.
Did you see? I think I see.